Hello and welcome back to Mr. Pog Talks About Math and Stuff. So today we're going to talk about the slope-intercept form of a line, right? So this is another form of a linear equation that we're going to be working with this trimester. So first things first, right? We got a couple different things that we've already learned about so far, right? We know about slope. It's a constant rate of change, right? It tells us how steep our graph is, whether it's going up or going down. It'll depend. We also have intercepts, right? We have an x-intercept and a y-intercept. So I got this little example drawn out over on the right-hand side of the screen, and all it does is it just gives you a little idea, right? If I have that red line on the coordinate plane, the x-intercept is where it's intercepting the x-axis. The y-intercept is where the line is crossing the y-axis, right? So y-intercepts are going to be pretty darn important to us as we go. We also have these two slope formulas, right? And by two slope formulas, I mean that there's one that's an actual formula and one that's a little less formal. So the first one there, m equals y2 minus y1 over x2 minus x1, is something that we have learned about already, right? What we're doing is we're taking the coordinates of two different points, x1, y1 and x2, y2, and using this formula to calculate for us what the slope is, right? And the slope, we use m to represent that. The other way that we can think about slope is by doing rise over run, right? So if you already have a graph and you can see where the little grid lines are and you can find two good points, you can actually just count out the rise and the run in order to figure out what the slope is. All right, so we're going to use a little bit of each of these here and there as we go. So the slope-intercept form of a line, the main attraction here, right? So just like with other ones, we can kind of set up a little bit of a skeleton for it, right? And these are the things that should stay the same, right? We're not replacing any of these. Right, what I would do is I would start it off just like this. Y equals blank x plus blank. Right, so when we're plugging things in, right, y equals mx, right? So m is the slope. Right? And then mx plus, and then at the end there we're going to put a b, right? And the b is the y-intercept. Right? So believe it or not, that's why they call it slope-intercept, is because it works with a slope and it works with the y-intercept. And that's really why. Right? So honestly, these are the ones that you may have heard about in the past, right? Y equals mx plus b might be something that's ringing a bell in your head. Right, so first things first, we've talked about point slope form already. This first example wants us to rewrite the following equation in slope-intercept form, then state what the slope and y-intercept are. Right, so first things first, we want to turn this into slope-intercept form. So if I'm looking at where I am down here, and I'm looking up top at, the general form for slope-intercept form, what I want to do really is I want to get the y by itself, and the other side should look sort of like mx plus b. All right, so the way that we're going to do that, the very first thing we're going to do is we're going to get rid of the parentheses. All right, so what I'm going to do is I'm going to take this 3, and I'm just going to distribute it into those parentheses. All right, so all those algebra skills we've worked up, right, coming in handy here. So over there, we're going to get 3 times x is 3x. 3 times that negative 9 is negative 27. All right, so parentheses are gone. That's our first step done. After that, all I'm really trying to do is get that y to be by itself now, right? So to do that, we have y minus 5 hanging out over on the left. I now need to add 5 to be able to move that over to the right. All right, so we're going to add 5 to each side. When I do that, those 5s cancel each other out, which is good. That's what we hoped for. And on the other side, we've got 3x, and then negative 27 plus 5 will bring me up to negative 22. All right, so what it wants us to do now is to take this equation that we just finished up writing, right? It looks pretty nice. Y equals 3x minus 22. And it wants us to tell what the slope and the y-intercept are. Right, so the slope, right, remember that it's y equals mx plus b, and I can actually pop that right back on there. So the slope, m, is just whatever number's hanging out in front of x. So my slope is 3, right? Another way that I could think about 3, and, you're welcome to think about it this way or just as regular 3. So we want to think about it as 3 over 1. Right? The reason we're going to do that is because then when we're graphing, we have both a rise and a run that we can actually put on the graph. All right. After that, we need our Y-intercept. All right. So our Y-intercept is just whatever number's hanging on to the end of our equation. So you might notice up top that like skeleton form of it has a plus sign in it. But the one that I'm looking at that's highlighted in yellow has minus 22. All right, so what I'll tell you is that when you're taking the Y-intercept, you're grabbing that whole chunk, whatever it looks like. All right, so our Y-intercept is actually negative 22 on this one. Right? So in contrast to, point slope form that we've looked at in the past, this one's not trying to lie to you, right? If it looks like minus 22, the Y-intercept is minus or negative 22, right? This one's pretty similar, right? If you want to give it a shot on your own, you can pause here and give it a go, see how it goes, right? If you're feeling a little shaky, we're going to talk through it together, right? So whichever camp you're in, we're going to start off the same way, hopefully. I'm going to take this negative 1/2 and I'm going to multiply it, distribute it into those parentheses. All right, so I've still got y plus 2. Over on the other side, we have negative 1/2 times x is just negative 1/2 x. And then negative 1/2 times positive 8 will bring me down to negative 4. Okay, cool. So parentheses are gone. After that, I just want to get that y by itself. So I'm going to subtract 2 to move that on over, right? Using what we know about multi-step equations to do that. All right, so that negative 1/2 x stays the same. Negative 4 minus another 2 brings us down to negative 6. And honestly, that's it, right? So then if I'm asked to find the slope, it's one of those things you see on the internet sometimes where it's like, find x, here it is. That's what we're going to do here, right? The slope is negative 1/2. And our y-intercept is that entire thing negative 6, right? So again, if it has a negative sign there, that is included as part of the y-intercept. If it's positive, if it's like plus 6, it would just be regular old positive 6, right? So hopefully that seems pretty okay. Let's take it one step further. Right? What we want to do here is we want to write the equation of a line in slope-intercept form that has a slope of 5 and goes through the point 2, 3. All right, so there's a couple different pieces of information that are going to be important to us here. If we have a slope of 5, that's m. Cool. If we know we go through the point 2, 3, right, normally what we do is we call that like our x1, y1, right? That's how we've been talking about points so far. So depending on, who you go to and who you talk to and how they learned it, they might have a slightly different way to do this. But what I find the easiest is to just use what we already know and work with that to turn it into slope-intercept form. Right? So what I have so far is I have a point and a slope. So what I'm going to do is I'm going to start in point-slope form. Right? So our point-slope form is that y minus y1 equals m, and then x minus x1 in some parentheses, right? So that's something that we've already learned about, right? So again, what I like to do is I like to use information we already know and then just build on top of that so you don't need to learn any new fancy way. So I've got it in point slope form, but I want to get it into slope intercept form. Right, so honestly, all I'm going to do is I'm going to do the same thing as what we were just working on a minute ago. I'm just going to take this equation and I'm going to solve it so that y is by itself and that those parentheses are gone. All right, so first step, I'm just going to distribute that 5 into there. We're going to get y minus 3 equals 5x minus 10. All right, sorry, the pen's a little freaking out on me a little bit. So then after that, all we got to do is get that y by itself, which means we're going to add 3 to both sides. All right, so we're going to get that y is equal to 5x minus 7. Right? And honestly, we're done. That's it. Right? We have it in slope-intercept form, right? We've got our slope here, which is 5, and we've got our y-intercept over here, which is negative 7. And that's it. That's all we got to do for these. All right, so again, there can sometimes be other ways that may or may not be faster for you, right? But again, we're using what we already know, working off of that. That's what I find easier. If you want to talk about the other way to do it, we can do that definitely. Make sure you ask me during class and I'll talk you through it. Right? You also don't need to, label them like I'm doing here. right? But just in case it helps you visualize what's going on, right? We did a couple of steps, now we're in slope-intercept, right? This next one's pretty darn similar. What I'd like you to do is if you're feeling pretty confident with it, you know, your slope is -1/2, your point is -8, 6 for your x1, y1, go ahead and give it a shot. If you're back with us or if you just wanted to talk through it together, that either way is fine. Now what we're going to do is y minus y1 equals m, which is our slope. And then we're going to have x minus x1. All right, so you might notice that over in those parentheses, I have a double negative, right? Remember that the point slope form has subtraction already built into it. So when we plug in -8 for that x1, both negatives are supposed to be there. All right, what we're going to do with that double negative is we're going to turn it into one big old plus sign. All right, make our lives a little bit easier. All right, I wrote a little too close to the top again. Let's scooch this down a wee bit. We're going to go the same way, right? First things first, I'm going to distribute our slope into the parentheses. I'm going to take that -1/2 and multiply it in there. So we're going to get y minus 6. -1/2 times x is just -1/2 x. -1/2 times +8 is -4, just like it was last time we ran into it. Right? And then our last step is to just get the y by itself. So I'm going to add 6 over here, add 6 on the other side to make things nice and even. And y is going to be equal to -1/2 x plus 2. Right? And again, now we're in slope-intercept form. I have my slope, which is -1/2, and I have my intercept, which is +2 over there. Right. So hopefully this doesn't really seem so bad, right? I know that it's not like, ooh, look, so much fun, yeah? But hopefully it doesn't seem so bad. So what can sometimes be even easier is finding the equation of something that's already graphed, right? So we want to write this equation in slope-intercept form, and here's how we're going to do it. Right? Our first step is going to be to find the Y-intercept. And actually, let's make sure everything's nice and color-coded. Find the Y-intercept. All right, so first things first, my Y-intercept is right down there. It's right at -4. All right, so it's something we already got. After that, we're going to find a second point and rise over run to get the slope. All right, so when we're looking for a second point on the graph, and I'm going to kind of zoom in on it a little bit more just to, try and make it as clear as possible, is that we want to choose a point that matches up with these grid lines here, right? So I want something that's nice and easy to count from, right? I want to make sure that I'm not missing like, oh, it's actually 2.2, something like that. So that purple point, that Y-intercept, is a good point, right? It's right where the grid lines cross. If I was looking for other good points, I could choose this one right here. It's right on the grid lines. Could choose that one there, or this one here, right? Or I even have one up there, right? So any of those would work just fine. What I would not suggest is don't choose something like that one there, right? You don't know if that's right halfway between those other two lines, right? We can't really count that well. Definitely don't choose something that's floating out in space like right there. That's definitely not going to be that great because I have no idea right where the coordinates are for that. All right, so any of those blue points would work. What I would suggest is choose the one that's closest, right? So to figure out the slope, what I'm going to do is I'm just going to count from this purple point over to that first blue point that we'd run into. All right, so when I'm doing that, my rise is 1, 2, and my run is 1. All right, so my rise was 2, my run was 1, and 2 over 1 is the same thing as just 2. All right, so my slope is 2. All right, so now we have our slope and we have our Y-intercept, and we're going to throw it all together. All right, so to write this slope-intercept form equation, we got y equals m x plus b. right? And this does look a little bit strange, right? You have plus -4 at the end of there. So normally what we would do is we would just write it out with a minus sign instead of plus negative. Right, so our final answer looks a little bit better if we throw it together like this. Right. So that's what we're trying to get to, right? It is a little bit, I think it's a little bit easier to get the equation from the graph than it is to get it from just some information like we were working on before this, right? But, you know, each has the pros and cons. All right, so let's try another one out, right? If you want to try the next one on your own and pause here and leave this one up as an example, not a bad idea, all right? So let's talk through this next one together. All right, so my very first thing I want to do is I'm going to grab my Y-intercept. So my Y-intercept is right there. It's up at 2. All right, so positive 2 is my Y-intercept. For my slope, right, I need to find a second point that'll be real good to work with. So what I'm doing is I'm going from here and I'm just kind of traveling along the line looking for something else that would work. So what I'm seeing is that the first one that looks pretty good is way over there. Right? You could also look over here, right? And that would be another good point that would work. But what I'm going to caution you is that when you're figuring it out, right, when you're doing your rise over run, read your graph from left to right, right? Don't try and go backwards with it because things might get a little bit confusing, right? There might be some in the future that we're going to talk about where going backwards is our best option, right? But we're not there quite yet. So for right now, we're just going to read it from left to right. So to figure out my slope, I'm going to go from that purple point to the blue point that I left on the screen. So my rise, quote unquote, is -1, right? And my run is 1, 2, 3, 4. All right, so my Y-intercept is 2. My slope is -1/4. And then all I got to do is throw it together, right? So it's Y equals mx plus b. All right, so -1/4 x plus 2. That's how we would describe this line that we got on the graph there. All right. So hopefully it doesn't seem so bad, right? Writing the equations of points, or slope-intercept form equations, you know, does require a little bit more of us sometimes than point-slope ones from graphs, right? But, you know, overall, it's not too bad, right? Let's get into actually graphing some of these together, right? So we got a couple steps in order to graph slope-intercept form. They might look pretty similar because it's kind of similar to how we're writing the equations themselves. So what we're going to start off by doing is we're going to plot our Y-intercept, right? So that's my very first thing I want to do is plot the Y-intercept. After that, we're going to use rise over run with it from our slope, and we're going to find a second point on the graph, right? Once we have 2 points, that's all we need. We can graph the rest of the line, right? And that's really all it is, right? So let's take a look. It's one of those things that's a little bit easier to see when it's done than to just talk about. So we got 4 different equations here. We're going to put them all on the same graph. So what I'm going to do is I'm going to try and color code it as best I can. So this first one I'm going to do in red. Y equals 2x plus 5. So when I'm doing 2x plus 5, I need to identify my Y-intercept because that's what I want to start with. So my Y-intercept here is positive 5. Right? So I'm going to go to positive 5 on my Y-axis, and that's where my Y-intercept for that line will be. Right? So that's my first point. After that, I need to figure out what my slope is. Right? And in this one, my slope is 2. Right? And again, we know that 2 is the same thing as 2 over 1, so that gives us a rise and a run to work with. So what I'm going to do is from that initial red point, I'm going to go up 2 and over 1 to the right. Right? We're moving in a positive direction. Give me a second point right there. Right? So now that I have 2 points, all I need to do is go ahead and connect them with a line. Right? So let's see how good I can do. Zoop. Not the worst, a little squiggly here and there, but pretty good overall. Right? I'm going to let you in on a secret. I used a ruler, but you know. So that's it. That's our entire line. It's all done and graphed. Right? Let's try another one out. This one I'm going to do in blue. Right? Something I will mention is that, you know, if you're doing everything all in the same color, that's fine. Right? What I would ask in that case is try and get in the habit of labeling them. So it's like, all right, that one's y equals 2x plus 5. I'll also label this next one once we get it done. So for the blue one, again, same idea. I need to figure out my y-intercept, which appears to be 7. So I'm going to go up to 7 on my y-axis, pop that blue dot on there. Okay. After that, I got to grab my slope, -4, which again, -4 over 1 is a good way to think about it because then we have a rise and a run. So what I'm going to do is from that blue point, I'm going to drop down 4, 1, 2, 3, 4, and go over 1 to land right there. All right. And again, after I do that, the only step I got left is to just go ahead and connect them with a line. Zoop, not too bad. Oops. I'm moving around a little bit. And again, if you're doing this all in one color, it might be helpful to label them, right? Just like a little tiny thing, y equals -4x plus 7. All right. Let's try another one out. Let's do this one in purple. All right, so again, starting off with my y-intercept. This one is -4, right? So be careful with those negative signs. Don't forget that they do make a difference. So my y-intercept is down at -4 right down there where that purple point is. After that, my slope is 2/3, right? So that means that I'm going to rise 2 and run 3, getting my second point over there. All right. And again, after that, it's just a matter of connecting the dots, literally. Not too shabby. All right, one left to go. Let's go with green. That looks like a nice color. Ooh, nice forest green. Reminds me of trees. So I got my y-intercept at -1. And my slope is -4/5. All right, so something we've talked about a little bit, and I'm going to kind of zoom in on just that part for a second, is that when we have a slope like -4/5, all right, we can think about it in any of these ways, right? We can think about it just like it is, right, which doesn't really help us all that much when we're thinking about where to put different parts of our line. We can think of it as -4 over +5, which is what I'm going to choose to do, right? That's what I would suggest. Or if I really wanted to, I could think about it as 4 over -5, right? So when you have a fraction and there's just one minus sign, you can think about it in any of those ways when we're doing slope, okay? So again, I'm going to choose that middle one where it's -4 over +5. So that's telling me to go down 4 from that first green point and then go over 5. Just spit me out right over there. All right. And again, last but not least, connect them with a ruler. All right. Or the edge of a book or the edge of something, or you can freehand it if you're feeling confident, whatever works for you. All right, and again, oops, don't erase the whole line after you do it. That's a bad move. All right, but after that, throw some labels on there. I forgot to do one over here. All right, and then we're good. Right? Doesn't that look like a mess? So we're not often going to be graphing like this many lines on the same coordinate plane, right? But I didn't want to give you a bunch of paper that's like 18 pages long to graph 8 lines, right? So this is what we're going to do. So I'd like you guys to do is pause here if you want to have an example on the screen. Try out the 4 lines on the next example, right? So try graphing those. Okay. So what we're going to do from here, right? I'm just going to run through them real quick one at a time. We got y equals 5x plus 1. So my y-intercept is 1. My slope is 5 divided by 1. All right, so y-intercept up at +1. My slopes tell me to go up 1, 2, 3, 4, 5, and over 1 to land me right there. And we're going to connect them with a line as I kind of scooch the screen around by accident. All right, next one on there. Y equals -3x plus 6. So my y-intercept is +6. My slope is -3 over 1. All right, so I'm going to start up at +6 where that first blue dot is. I'm going to go down 3 and over 1 to get my second point. And again, just throwing it all together with a line. Okay. After that, y equals 3/7 x minus 8. So again, on this one, be careful of the negatives. That -8 really should be -8. And then my slope is 3/7. Right, so my y-intercept is way down there at -8. After that, I'm going to go up 1, 2, 3, and over 1, 2, 3, 4, 5, 6, 7. All right, which hopefully lands us right there. Right, and again, throw it all together with a line, and then we're done with that one. Okay. Last but not least, we got y equals -2/5 x minus 3. So that minus 3 is our y-intercept. -2/5 is our slope. So I'm going to start down at -3 on our y-axis. I'm going to go down 2 and over 1, 2, 3, 4, 5 for my slope. All right, now that we got those 2 points, just connect them together. NBD, as they say. All right. And honestly, that's it, right? So I'm hoping that slope-intercept form doesn't seem so bad, right? All we're really doing is, we have a y-intercept, right? So we're either going up or down on that y-axis in the middle. And then afterwards, we're using our slope to get a second point and graphing it out, right? If you have any questions, be sure to ask them when I see you next time, all right? Other than that, check on Google Classroom to see if there's any additional stuff I threw out on there, and I'll see you next time. Bye.